All right, thank you, Park. It's great being here. So today I'm going to talk about our reporting and experimentation platforms that we have built at LinkedIn and how over the past couple of years this has allowed us to accelerate our product innovation. So before I get into the details, let me share with you a true story from our production experience. This was a few years ago. And for those of you who work in sort of these online companies, this is probably not too unusual, right? And I think from some of the nodding heads, I can tell you guys have all gone through this, which is once in a while you see some event where your key metrics have a sudden drop. In this particular example, it happened to be a serious drop in the ads click-through rate, right? And this was in the previous iteration of the product. So as you can see, there is a little space right above your profile where there is a little bit of space to have an ad. And that's the click-through rate that is being monitored. And as you can see, for most of the traffic, there is a fair amount of predictability in terms of, depending on the day and time of the day, the traffic goes up and down. So it's fairly predictable. And when you see a sudden drop like that, it is a cause for concern, right? And what typically happens in this case is all the folks involved get into a war room. So literally people from multiple teams are together in a room and there's a bunch of hypotheses of what could have gone wrong. And the space of what could have gone wrong always is rather large, right? Maybe you change some machine learning model in the back which changed the relevance of the ads being shown to the users and therefore people stopped clicking on it as much. Or maybe it was a back-end service problem. Maybe the latencies of the ad serving went up, so that could have caused the issue. Or maybe it was something to do not with any software changes. Maybe it was a network outage in a country where you have a lot of traffic. Or maybe it's a holiday in some countries. So whenever you have these changes that you have to kind of go and figure out what is it that's going wrong, it tends to be a rather laborious and expensive process. So before in this particular case, I tell you what was it that happened, let me take a step back and give a brief high-level intro on how do we build data-driven products at LinkedIn. And when I'm talking about data-driven products, I'm talking about it in a fairly broad sense, right? So if you go to LinkedIn and you have a product like People You May Know, which is a recommendation for people to connect with, that's a data-driven product. Your feed, where we are effectively suggesting to you, recommending the updates from your network that you might be interested in, that's a data-driven product. So that's a fairly large space. And how do we go about building it? Now it's a collaboration effort between multiple teams and multiple roles. So you have the product managers, you have designers, you have engineers, and you have data scientists, right? And product managers are thinking about what are the new features to build on, say, the profile page. And then they're looking and working with designers to actually how to build that experience as part of the site. Data scientists and analysts are helping answer the questions of how might that feature might work when it's built. And a lot of that analysis might come from a lot of data that's been collected in the past and user behavior that you can kind of analyze to predict. And a lot of that data is collected by very detailed instrumentation of the code that your application engineers are writing. So that's kind of the flow which is typical for a lot of data-driven products. So let me take an example of, like how that would start with. And for the website and a lot of our mobile applications and so on, you would do what we refer to as tracking data in a very detailed way throughout your application. So for example, you see the My Network page here, and against people you may know, you have this little button to invite somebody to connect with you. So when you click that, it generates what we would call an invitation click event, which basically is generated for the front end, and that helps us know that you have actually invited this person to connect with you. And the metrics around that are then basically counting many of these events depending upon what the case might be. And this is an example event, and if you look at the entirety of the application, there's literally thousands of different kinds of what we call tracking events, and which power, again, hundreds to thousands of different metrics, and also data products that might use the same data in order to generate machine learning models for recommendations and so on. So this is a very high-level data lifecycle of how this data gets generated, produced through the applications, which is generating user data, the engagement, and the tracking data, which then gets transported into our infrastructure platforms, primarily the Hadoop-based ecosystem and Kafka for offline and near real-time computations. And the way this data gets consumed, primarily you could think of it as two different ways. One is your member-facing data products, which would take a look at the data, run a lot of computation using machine learning to make the site more relevant and personalized to you. And the other way the data would get analyzed as consumed is through generation of a lot of detailed metrics, which in some cases might just be consumed internally by executives making business decisions and product managers, or it could surface as metrics as part of some site-facing features. And like I mentioned, this is also a collaboration effort with different teams and different roles. For example, when you are talking about the production of this tracking data, that's largely a decision and working between the product managers who will decide kind of what are the features that need to get built, what are the success metrics for it, what are the things that they would like to track and measure, the developers which would implement those features, and instrument to collect that data, and test engineering who would sort of make sure that you are actually tracking and measuring the right things. As you move into transport, it becomes more of a concern of the infrastructure teams like ourselves who maintain platforms like Hadoop and Kafka, other platforms that make up the data warehouse. And these platforms are then heavily utilized by our data science teams, which could be the engineers who are working in machine learning, or other data scientists and analysts who are trying to understand this tracking data in order to make inference about the products and decisions. And then those will be surfaced to our members as well as internal users. So how do we calculate these, and what do these tracking events and the metrics look like? So one of the decisions that we made early on at LinkedIn was to be very structured about the schemas of our events. And we didn't always start out that way, but over the years, we've kind of been more and more disciplined about it. And that's for a very good reason, because as the application and the organization itself has scaled, having sort of too much flexibility and loose schemas cause a lot of problems in downstream analysis, because it's very easy for the people who are writing the code to emit whatever they want. It's very agile. You can emit any arbitrary JSONs with maps and other things embedded, but it's the analysts and the ML engineers downstream who now have to kind of parse it and handle all kinds of exceptions. And we've gotten much more value out of being structured right out of the gate. So we've standardized on Avro. This is pretty much what most of the tracking events at LinkedIn would look like. So going back to our example of the add CTR drop that I started with. So this is roughly what the click event and the impression event would look like. So add impression event is generated every time you see an ad. when you click on it, we would generate an add click event, and computing the CTR is just a matter then of summing up those metrics for whatever time window you're interested in, and it's a simple ratio. So going back to our example of add CTR, this turned out to be something that at the time, to the engineer implementing it, would seem completely benign. Right? It wasn't a machine learning model. It wasn't a big service change. It wasn't a big product rollout. This was literally a 5-pixel change. The bar that you see right on top of the ad, that was moved down by 5 pixels. And if you are a UI engineer who's implementing it, that seems like, yeah, that's a very, very tiny change. You wouldn't bother to think through very deeply about what change it might cause. But the effect of that can be rather significant. Think about it, just a 5-pixel change on your page, and it's a very significant drop in your ad CTR and therefore your revenue. So if we had done something called A/B testing at that time, and this was a few years ago, and if you had done it, we would probably caught it and not actually ramped that feature to everyone, right? So I assume most of you know what A/B testing is. For those of who don't, this is a very, very quick A/B testing 101. So let's say you have your existing flow, whatever. This is a new member registration page, and you decide, okay, I'm going to make what seems like a small change. I'm going to try with the green button and see how that works. So what you would do is effectively partition up your traffic. You would send most of your existing traffic, say 80% of it, to your existing experience. Pick a small percentage of the traffic, say 20%, send it to the new experience. Collect the events and the results, and decide which one performs better. And if the new one is performing significantly better, then you would start ramping it up till it's ramped up to all your members. If it's performing worse, then you would roll it back, see what's going on, and fix it. Right? So this is what you would call the control, and the one on the right, you call it a treatment, and you could have multiple treatments. And as you go through collecting the data from the experiments, you will continue to ramp up the one which is performing the best. Couple more examples. So that was kind of something that you wouldn't expect, and practically everything else that we do, including small feature additions or big product rollouts, would absolutely go through significant amount of experimentation. So this is an example of a profile edit page, and we prompt you to enter your interests, to add more details to your profile. A simple addition of that one line, which basically tells users why we are asking for that information, again, seems like fairly straightforward. It's just a one-line change. Increase the profile edit completion by 14%, right? So it's a pretty significant change. And of course, when we do some significant product changes, like when we completely redesign our payment flows, something like that would go through an extensive experimentation, which over a time period could be fairly lengthy. And as you can see, something like that would result in a significant change in your important metrics. So in this particular case, you had like a big reduction in your refund orders, increase in your free trial orders, and millions of new dollars in bookings. So what do you A/B test, right? Of course, if you have new algorithms that improve or meant to improve your relevance and recommendations, yeah, you want to A/B test it and see what works the best. Back-end service changes, you use new services, you're cutting over traffic. That's something that you want to test, how that impacts your performance. New configuration changes that would, again, significantly alter the behavior of your services. Like I said, design, UI changes, sometimes they seem rather benign, but could cause significant impact. Evaluating different models to see what performs better, new feature ramps. So in short, our philosophy at this point, LinkedIn, is basically test everything, right? As a developer, whenever you are building anything, we want to make sure that the infrastructure and the platforms are not the bottleneck for why you wouldn't test something. No matter how trivial something seems, we want to make sure that we have the ability to test it as much as you would want to make sure that it actually has a benefit. So going back a few years, even before we started building a lot of these, we had a pretty good data ecosystem at LinkedIn, right? We were one of the very early users of Hadoop. We had a pretty large footprint. Kafka, of course, was built at LinkedIn, so we had tons and billions of messages flowing through Kafka. A very democratized data ecosystem where data scientists, analysts, engineers had the freedom to choose the tools that they wanted. Early on, there was a lot of Pig being used. There were people who preferred Hive. Over time, there was Spark. So you have access to all of the data. You have access to all of the tools. So you can pretty much do anything that you want. So what's the problem with this? One is, as an infra team, it's an operational challenge. For those of you who are in the space, you of course know it's like literally every other day there is a new engine or some framework, and there's always somebody who would want to use that, and it's a challenge to continuously keep following and chasing it, and sometimes you don't necessarily know whether it's just a shiny new thing or something with a lot of promise. The other, I would say the more important concern is one of trust in data. One of the side effects of having a very democratized ecosystem is the fact that now anybody is able to compute and analyze whatever data that they want. So let's say you were analyzing profile views. And unknowns to each other, different people working in different parts of the ecosystem might effectively measure the same things in rather different ways. So one data scientist measuring profile views might just count the number of all profile view events. Another data scientist counting profile views might decide that he wants to filter out bots, which is a good idea. And now when you're looking at profile view events, it's like, okay, what are the number of profile views that LinkedIn had in a day? These two numbers would be rather different. And oftentimes, what then happens is when you're looking at numbers to kind of make decisions about what went up and down, instead a lot of time and energy gets spent in reconciling these numbers because nobody can agree on what really the right number is. And this is actually like real, because in many cases you might have like half a dozen or dozen answers to pretty much the same question, and you can spend a lot of time trying to figure that out. So how did we solve this? So I'm going to spend most of my time describing the single source of truth system that we built called the Unified Metrics Platform. But let me show you quickly how it sort of fits into the overall data flow and stages at LinkedIn. So I talked a little bit about the creation of this data, creation of tracking data, for example. Then it's followed by an ingest phase where we pull this data into places where you can actually analyze and process it. Then, of course, you have the process phase, which actually running computations on the data. And then you have serving engines, which can then serve it to the users, whether they are LinkedIn members or internal users. And finally, depending upon the specific problem, some sort of a visualization layer, right? So tracking is one of the bigger use cases of data production at LinkedIn. The other one being Espresso, which is a distributed database that stores the user data of record. And these are kind of both systems that generate most of the data, which then gets analyzed at LinkedIn. So again, very quickly, looking at what the tracking architecture looks like, you have both services in the back end as well as the front end clients, which are instrumented with the SDKs to support different frameworks which are actually generating all these tracking events. They're published through tracking front end, or in the case of back end services, directly into Kafka, which is literally generating billions of events. And you have monitoring tools that kind of look at this entire pipeline to make sure that things are being produced correctly in the right format and the right events and so on and so forth. Moving on quickly to ingest. So ingest, as I mentioned, is a very democratized ecosystem. It's very easy to use. You can just pull in the data, and then you can analyze it. And then you have serving engines, which can then serve it to the users, whether they are LinkedIn members or internal users. And finally, depending upon the specific problem, you can we rely on a platform that we built in-house called Goblin. And when I told you that most of our data is generated through Kafka and Espresso, that's only partially true. Yes, it is true that a lot of the data is generated by those. But at the same time, we have a rather complex ecosystem where there are a ton of external data sources that are constantly being brought in, and that might be then joined with the other data in order to get some insights. And this was primarily motivated by the maintainability challenges that we had in building and operating more than a dozen distinct data pipelines. And each of them would then deal with the data quality issues and operational fires. And the number of sources, as it keeps increasing, trying to solve that with a small team is, you're effectively just constantly in firefighting scenarios. So about 3 years or so, we made a decision to kind of build a centralized ingestion engine, primarily to bring data from all of these sources, both batch and streaming, into Hadoop. Today, we also support a lot of other syncs as well, like S3 and streaming syncs as well. So pretty much you can use it to connect any number of data sources to any number of data syncs. At LinkedIn, we've been running this in production for a couple of years now, with hundreds of terabytes a day being ingested into Hadoop. It's been open sourced for a little bit, and there's a number of other companies that are successfully using it in production as well. So it's something I would encourage you guys to check out for sure. Moving into process, if you remember, I talked about this variety of tools that we have in terms of you could have Pig, Hive, Presto, Spark, all of these tools at your disposal to crunch this data and generate all these metrics and insights. What we wanted to do, like I mentioned, is not only have support that diversity, but also make sure that we have the trust in whatever it is that we're computing. So in other words, to build a single source of truth for all our metrics that we're measuring. And the principle that we wanted to adhere to is make sure that we are able to write that once and then be able to use it anywhere. And what that means is, let's say you're, again, counting profile views. Whether you are writing that in the context of being able to generate for an internal dashboard, whether you are counting that in order to show it to on the LinkedIn.com to a member experience, or whether you are using it in the context of experimentation, we should only have one single source of truth for when you ask what is the number of profile views. You should have it in a single place, no matter how you decide to use it. And what we ended up building is what we call the Unified Metrics Platform, which today is a single source of truth for all of the metrics. And this is actually even a little bit dated. We have like over 7,000 to 8,000 metrics already, and that number continues to grow almost every day. And when I say metrics in this case, I'm referring to a top-level metric like profile views or add CTR. Pretty much every metric can then be analyzed by tens or sometimes hundreds of dimensions. So when you put the whole thing together, you're literally looking at millions and millions of data points. So the flow looks something like this. Typically, it's an analyst or data scientist who's trying to build up a new metric. The process starts with some sort of an iteration in a sandbox and analysis to decide what it is that you really want to measure, because you want to make sure you're measuring the right thing. And once you kind of are satisfied with that, you would create that metric definition and submit it for a review. And you kind of have a distributed process for doing that, just like you would do code reviews. That metric definition logic would then get reviewed by the subject experts. For example, if you're building an ads metric, that would you review that by the people in that domain. If you're looking at profile view metrics, that's again reviewed by a different set of people in that domain. And once that is reviewed and you're satisfied that's actually the right thing, the user then just checks it into a code repository where all of these metrics are defined. And that is pretty much what, as a user, the metrics owner has to do. The platform then takes care of pretty much everything that happens past that. And roughly what that looks like, think of the UMP harness as a container for your metrics logic. The user is responsible for defining the logic. The platform is responsible for everything else, including making sure that the flows are scheduled correctly to meet the SLAs that are requested by the users. Do the incremental processing. For example, you might, as a user, you might want to create a windowed metric that looks back in the last 30 days. And if people are computing it independently, some scripts might do it very well. Some scripts might look at the 30 days of data every single day. And to remove sort of those factors from the equation and just make sure that we can guarantee that SLA, you would do that computation not in the user code, but in the platform logic itself. Things like backfills. One of the very common things that happens in metrics is you change it slightly. The definition of it is different from what it used to be, and now you want to measure for how that performed historically in, say, the last 2 years. That would then require you to backfill that new metrics logic, and again, that is something that you would want the platform to do. Just a quick example, I won't go into the details, but there are some things I want to just call out very quickly. One of the key decisions that we made was to separate out the user logic from all of the things that can be done as configuration. And when you have the right data sets that are already available to you, many times you can express your metrics logic simply as configuration rather than, and it's completely, in that case, it's completely code-free. In other cases, you would have some user logic to actually define the data set, and you have the ability to pick your favorite programming framework, whether it's Pig or Hive or Spark or just vanilla MapReduce. You can go ahead and do that. So a couple of things highlighted. One, look at the frequency and the output window. When we started building this platform, we had thousands and thousands of metrics which were largely daily, and that was something that we were trying to clean up in the beginning. As time progressed, we wanted to make sure that whenever there's need, you can actually take that same logic and now run it, say, hourly. And that was one of the first things that we did. And one of the benefits of doing it this way was you were literally overnight able to convert thousands of metrics from having to run daily to them running hourly, because all it was basically a config change. And the same thing is now playing out as we are effectively running a lot of the metrics in near real time to operate at much frequent occurrence. The other things that get declared in your metrics definition is the dimensions you want to cut those metrics by. So in this particular case, you're looking at the analytics around video plays. You probably want to know, okay, what platform are these videos being played on, right? Is it phone or tablet or desktop? What is the action type? Is it an autoplay? Is it a click play? You're defining the metrics in terms of what are the things that you really want to measure. So here you want to count the number of unique viewers, and you want to count the sum of the play actions, let's say. And again, note that these are simply done as declarations. The platform defines a certain library of aggregations that it can do, and the user simply has to annotate them as opposed to actually having to write the logic to compute the aggregation. Right? So quick roundup of the UMP by the numbers. Again, some of these are constantly, like going up. So this is probably accurate as of, like a few months ago. Every day there's hundreds of terabytes that are being computed over. We have over 7,000 metrics, each metric being cut by tens or hundreds of dimensions, hundreds of scripts written by hundreds of different folks within the organization, and a relatively small team of half a dozen engineers and operations folks who keep this pipeline running. So a few learnings to call out. One is, besides scalability, ease of onboarding is rather important when you have a large number of users with very different skill sets. You need a good user experience to make sure that this is something that people are actually able to leverage well. Single source of truth, the aspect is rather important, and I've covered some technical details. But remember, like there's a little bit of process around it also, and that is not just technology. That needs an active organizational focus and buy-in to really adopt the idea that you do want to build a single source of truth and then kind of go after it. Operability is hard. As a number of other speakers also observed, dealing with a lot of these distributed systems with SLAs is not trivial, right? And cost to serve through these thousands of metrics, which are not necessarily cheap to compute, is also rather expensive. The things that are being worked on, like I said, code-free metrics, a lot of metrics are being converted to real time. So essentially, the definition stays exactly the same as it were, and it would start working in a streaming context, leveraging Kafka, Samza, and so on. This is one of the things that we have not yet open sourced, but something that we do want to do down the line. And other sort of concepts that we want to kind of build into the platform, and today users would have to write code for it, for things like sessions and funnels, cohort analysis, and that is something that we would build into the platform over time. So having talked about UMP, let me quickly go through the rest of the A/B testing or the experimentation platform. And without getting into too much details, I'll cover sort of the different aspects of it. One is the design of the experiment itself. What are you experimenting and who's the target? How do you deploy the code for those experiments, and how do you analyze and understand its impact on metrics? So I'll talk a little bit about the online infrastructure to do the experimentation and the platform to do the offline analysis. In terms of the data flow, note that, this goes the right to left, but the data flow is rather similar in terms of the tracking events generation, which then flows into Kafka, then into your Hadoop data store, where you would run a lot of analysis, essentially joining the experimentation data with the tracking data, and finally generating those insights and then being able to serve it. So the first thing, how do you create a new experiment? Who do you target? How do you split the traffic? And how do you start and stop an experiment? And it's important to know what are the success criteria for your experiment. What are the metrics that you're trying to move? And if those metrics move significantly in the right direction, then you will continue with the ramp, starting with the small one. Right? And if those metrics are going in the wrong direction, then you need to slow it down, unroll it back, fix things, and then go back to trying it. So real quick, the way we do it is the members are mapped to, for an experiment, the members would be mapped to either one of the treatments or control based on a randomized hash ID. And for a particular experiment, you want to make sure it's consistent, so it's random for that experiment. And you would, every time you serve a particular treatment or the control experience to the member, we actually would log that fact that this particular treatment for this experiment was served to this member. At any given time, we have literally hundreds of different experiments that are running, and they're all active at the same time. So you, as a particular user, you are actually subject to all of those experiments simultaneously. Now, these experiments are largely independent, and the way you would do it is there is a randomized hash function per experiment. So in one experiment, you might, in this example, land in treatment B1 for experiment 1. For another experiment, you would get hashed differently, and you would end up in the control for that experiment. Right? In some cases, you do want to make sure that they are correlated. For example, there might be two different experiments that you're part of. One that's more related to a backend feature that creates a new experience. Another one that relates to a UI that is also related. And if they're not coordinated, then you could end up with a broken user experience. Right? Think of a backend service generating some data or aspect that the front end is not able to render correctly because it's not part of the same experiment. So you have the ability to do that as well, so that for a member, you'd exactly end up in consistent treatments. Data logging, something that I want to quickly call out, is one of the things that we log explicitly is not just the fact that you are for a target or in a particular bucket for an experiment, but rather whether it actually got triggered or not. And to realize the difference, think about, let's say you create an experiment and it's on a page that maybe doesn't get as much traffic as your homepage, right? So maybe it gets 10% of the overall traffic. So if you look at the traffic overall, 90% of your traffic is not actually going into that page, 10% is. Now, out of the 10%, let's say you are 90% is control, 10% is treatment. So 10% of the 10% might actually be triggered by a particular treatment. So even for the control in that one, even though you're not getting the new experience, you are actually logging the fact that for every request that is dependent on an experiment, you are actually logging the fact that we did generate a particular treatment or control for you. Now, as you can imagine, this results in very, very voluminous logging. This literally is one of our largest Kafka topics that we have at LinkedIn. But there's a lot of value in doing that, so you can generate a lot more accurate insights. And this is the way you surface those analysis to the users and the experiment designers. And the statistically significant movements in your experiment, whether they're negative or positive, would get highlighted, and the experiment creators can then follow the progress of their experiments. In addition to a lot of the technical developments in the platform, the other thing that we're very conscious of is also the collaboration and communication aspects of this, right? And the reason this is necessary is in a relatively large ecosystem, you have many different experiment owners, and you have a lot of different metric owners, and those two don't necessarily overlap. So you might create an experiment, and you are interested in moving a certain set of metrics which you are very focused on, but whether you know it or not, you might end up affecting the metrics that are owned by others, and then you're not necessarily monitoring them. And if you're a metric owner, you don't necessarily know which of the hundreds of experiments that are running live are actually affecting your metrics. And this is something that through this product we can enable, connecting these different experiments with these different metric owners. And the way you typically do it is something called the most impactful experiments. So if you're a metric owner, you can actually go to this product, Excellent, and monitor the metrics that you actually care about, right? And whenever there are experiments that move it significantly, you would basically get emails telling you that there are these experiments which move your metric in either positively or negatively. Then you can reach out to the experiment owners to kind of get the dialogue going. So as I mentioned, that visibility and to enable responsible ramping of your features and having that active communication between the metrics owners and the experiment owners is very crucial to making this successful. One other quick aspect that I want to call out is this thing called site-wide impact. And going back to the previous example, let's say you run an experiment and you have, like some meaningful metric movement, let's say 10%. But remember, maybe you are in a page that gets very little traffic, right? So, or maybe it's a very small bucket. So when you actually ramp it even for the entire one, that actual effect on the metric would be a lot lower simply because now you're looking at it in the site-wide context. And the reason that's important is the site-wide impact is the results comparable across different experiments and also consistent with the reports that your product owners and executives are looking at. Let me skip this one and go to the next one. Again, this is a little bit dated, but as you look through it, as we built up this platform, there's been a tremendous explosion in the number of experiments that people are running, right? And that's a good thing. We want to keep that going. and the platform itself has scaled quite well. We process tens or hundreds of terabytes of data. This was sometime last year. We had 3,000 metrics. Now it's double, and I expect they'll just continue to grow over time. Let me just quickly talk about the two aspects, which are serving and then visualize. I won't spend a lot of time there. Serving, we have basically a distributed multi-dimensional OLAP engine called Pinot. Again, I won't get into the details of the columnar stores and indexes. Most of you know that well. And the reason to do that is, like I mentioned, for any metric, you have lots of different dimensions that you don't necessarily want to pre-compute the entire world. So having something like this, like Pinot, which is able to do that slice and dice as real time, is rather useful to us so that we can do that partial computation, stick that data into Pinot, and then have Pinot kind of do the slice and dice to kind of do that final grouping. And in addition to having a very low latency to queries, which is often in milliseconds because a lot of these experiences are actually site-facing, and you need that very low latency. The other important feature is near real-time ingestion. So it's not like you have to do hourly loads into your data store and so on and so forth. This is something that we have been using at LinkedIn for a while. We open sourced it, and there is a bunch of other companies that are already using it. Uber is one of the ones that we know is one of the larger ones, and as you can see, there's a bunch of reporting dashboards, site-facing features, experimentation dashboards, which are powered by this. In Visualize, we talked about Excellent and dashboarding already. One other thing that I want to call out is the first example that I talked about, which was a sudden drop in a metric. A lot of the times that is actually because of software changes. And when it is, things like A/B testing will help you catch it much earlier before you ramp it fully. In many of the cases, it's not related to a code change. It might, like I said, might be related to events that are external to you and not in your control. And for that, we built an anomaly detection platform, again, leveraging the same pieces. And again, having that ability to have a single source of truth of metrics is rather crucial, because now we can monitor the same metrics and the user doesn't have to do anything else. The fact that you've already onboarded that metric onto UMP now gives you the ability to monitor all those metrics and get notified when there is a substantial movement. So this is an example. That platform is called Third Eye, and this is an example email that you would get if that's a metric that you've been monitoring, right? And once you click on a particular metric, you would go into a little bit more detailed analysis in terms of saying, hey, what's the window where the anomaly occurred? And this would also get user feedback, because this is something that is being generated through machine learning models. And that user feedback in terms of getting input on whether we detected anomalies correctly or not is constantly improving the platform. And some of the other things that are not shown here, it actually also monitors the various dimension combinations simultaneously. So even when you know the top level metric has moved, you don't have to do a lot of unnecessary guesswork to do your root cause analysis. So again, to tie it all back together and to summarize, the focus on measurement has been crucial to a lot of the data product innovation at LinkedIn. As we like to say, you can't fix or you can't improve what you can't measure. The single source of truth in measurement has been a huge game changer for us, right? And another point that is worth stressing is technology alone is not enough to make something like this successful. You do need to pay attention to the organization that is part of making, is responsible for making this successful, and have that cross-team focus in order to make sure you're getting the right results out of this. So that's all I had. If there's time, I can take one or two questions. Otherwise, I'll be around, happy to take questions offline as well. Thank you.
Excuse me. How do you handle sensitive data, personally sensitive data tracking and storage as all of these massive streams are collaborated and shared?
So the question was, how do you handle sensitive data? So it depends on the context. So a lot of the data that is used for reporting and experimentation, depending upon what is it that you're measuring, a lot of the times, you're doing it simply based on the events as opposed to sensitive information that's actually included in those. For example, to do the correlation of members to experiments and trying to do that inference doesn't actually really need a lot of personally identifiable information, right? So that is not something that may be there in those events, or if it's there, it will get filtered out before it actually pipes in. Depending on the privileges that you would have, in our platforms, especially for computations that happen in Hadoop, we also run, secure Hadoop clusters. So we have authentication in terms of knowing who it is and in what context and what are the accounts that are actually using that data and for what purpose. And that's one of the ways that, making sure that we are, treating the data in the right manner. Sorry, say that again? I couldn't hear you. Yeah, we do, and we can discuss more offline if you're interested. But yes, depending on the kind of data that you're looking at, yes, there is different levels of privacy. Thank you.